day 2, which really is topic 2 because we're going to spend today, Friday, and Monday on it. This one's going to be due on Wednesday, next Wednesday. So we're going to spend 2 days on it, and then you get a day to get caught up. That's how most of these will go. All right. So whenever you're looking at problems like this is going to seem really familiar because of the after parties. You've been doing these problems. They've been on a lot of the after parties. And this first page is just going to review all that kind of stuff. So when you see a graph like this, first of all, you got to know what this is a graph of, because typically there's 2 functions. And so right down here we have big F equals the integral of little f. So I'm going to write that in shorthand right here. Big F equals integral of little f. And you need to know if this is the graph of big F or little f, and it is going to tell you. So it says that's what this is a graph of. This is a graph of f, little f. All right, and so integrating f, all right, on this would look like area, right? If I was integrating that graph, and if I were to take the derivative, I would get big F prime. And what's the derivative of the integral of f? Just f. And that is this graph, because this is the graph of f, so we would put y values next to it. He's coming back? Yeah. That should be a b. Right. A lot of times it's f and g. Here it's big F and little f. All right, and then I'm going to say big F double prime then will equal little f prime. And what would that represent on this graph? Slope. Slope. All right, if you can set this up on these problems, it's going to make your life easier, because no matter what or the AP test asks you, you can go back and look at this to be able to kind of sort through your work. Otherwise, it can be confusing because they're not going to ask you, when is this graph increasing? That's something an Algebra 1 student could figure out. All right, they're going to ask you, when is the other graph increasing? So they're always going to ask you questions about the other graph, given this graph and given this equation. And so when we look at filling in this table, all right, let me scroll up just a little bit here. We have this, we're going to integrate from 0 to whatever x value they give us, okay? And I'm going to do this work over here, all right, just so I have room. So to find f of -3, I'm going to integrate from 0 to -3 of f, all right? And this is kind of shorthand, so I'm not writing it all out. This is just scratch work anyway. First of all, are these 2 numbers in the right order or wrong order? Wrong order. Okay, so I'm going to go ahead and write a minus, because whatever the true answer is, integrating between these 2 numbers, we should negate it. That doesn't mean our answer is negative. It means we're going to have to multiply it by a negative. All right, and so if we look between 0 and -3, and I find the area of that triangle, what is the area of that triangle? 1/2 base times side, 9. Okay, so the area of this triangle is 9. The integral from -3 to 0 is -9 because it's below the x-axis. But we also have this being in the wrong order. So it's like we have a negative, it makes a positive 9. Let me repeat that. It's positive 9 because the area is 9. I'm going backwards because you have to start at 0, and I'm going below the x-axis. That's why this is positive 9. All right, so then we're going to do 0. This is the easy one, because what do you get when you integrate a number to the same number? 0. There's no, it's like a vertical line. There's no area underneath that, because there's no span that you're going. So that's easy. Okay, 3, 0 to 3. So we're going in the correct direction now. And but it's still underneath the x-axis. So this, I'm going to choose symmetry there. I know that's 9. But this is the one that has to be -9 because there's only one negative. Going in the right direction, but underneath the x-axis, -9. Are there any questions about why one of these was positive and one's negative? You see the difference? All right, so then moving on, 0 to 5. Okay, what a lot of students are going to want to do here is they're going to want to go to 5, and they're going to want to say, hey, this is 1/2 times 2 times 6. That area is 6. And I'm done. My answer's 6. Right. You have to add it to this -9 because it has to be from 0 to 5. It can't just be that last shape. It has to be all the way. So if I know this area is 9, I'm going to do -9 plus 6, which makes -3. And this is how you always find integrals when you're not given an equation. You just do area. So we're not really doing Riemann sums here. We are finding the exact answer. And I can do that because these are lines and not curves. If these were curves, I could only estimate with Riemann sums. All right, 8. That would be all the way to the very end. This is a 3 by 6, so that's 18. But I got to add it to the -3, which makes 15. Okay, any questions? All right, so then there's going to be all these questions here. Okay, so the first one says where. They actually all say where. So when you see this word where, is that referring to X or Y? X. Where, or what's another question that you put there? What's another question that would also tell me if they're talking about X? When. Where or when would be X values, what would be a Y value. Now this is where is the maximum of F. This does not say relative or absolute. So we're actually going to do both. And then we're going to have an ongoing conversation today and Monday about the difference. So let's first do the relative maximum. Okay, so there's going to be a relative maximum of F when big F prime, which is the same, so I move up here, as little f, does what? You have a relative max. You think about it like a hill. When you're going up and going down, so positive to negative. And then this is all shorthand here. This said justify your answer. We probably want to write it out a lot neater than this, all right? So where is, is this talking about, this is talking about y value. This is why you want to do this, because I can look right here and say, oh, that's saying y value. So where's the y value going from positive to negative? So something is happening at 3. But it's the opposite of what you guys are saying. It's going from negative to positive. So at x equals 3, that's actually a relative minimum. All right, so where's the relative max? There's not one. All right, so we'll just say no relative max. There's no relative max because the y values on this graph do not go from positive to negative anywhere. Okay, that means then if we're going to do absolute max, then I need to consider an endpoint. Absolute minimums and maximums can be your relative minimums and maximums, or they can be your endpoint, and you will always have an absolute on a closed interval. So the absolute max, since there's no relative max, we got rid of that, it's either going to be from the left endpoint or the right endpoint, and you just pick the bigger one. And so I can see over here that's obviously bigger. So this is going to be what we call our absolute max. The actual max is 15. Where is that max? That's at x equals 8. All right, so let's do, I'm going to skip B for now and let's do C. Where is the minimum of F? Okay, so let's do the relative first. The relative min would be at x equals 3. All right. And what about the absolute minimum? Is it also at x equals 3? Yeah, look. If I consider 3, like consider your 2 endpoints and consider 3, the very smallest number is that -9. That is your absolute minimum. That means that that's happening at x equals 3. So we'll continue to have this conversation of how do you know when it's which, all right? But on here, we just went ahead and moved both of them. So where is F decreasing? Okay, so F, big F is decreasing when F prime, big F prime, which is the same as little f, is positive or negative? Negative. Big F is decreasing when the slope of that segment is negative. And so we're going to look back up here again and we're going to say, hey, yeah, okay, that's y values. So all I really need to look for is where the y values are negative. And the y values are negative from -3 to 3. And again, if this was one where it's a justify your answer, we would probably write it a little bit cleaner than this. It's kind of just scratch work. All right, so you do D on your own. Okay, so where is this big F increasing?
3 days. 3 days.
3 days. Now, are any of you concerned about these parentheses versus brackets? Could I put brackets here? You might see them as brackets sometimes. It's not a big deal. The AP test accepts them. All right. Points of inflection. All right. Points of inflection have to do with the second derivative. Okay. So where are the points of inflection? It's when the second derivative, which is the same as little f first derivative. We can't just say equals 0. That's a mistake here. That's not quite good enough. We have to actually say changes signs. And if I look up here, I'm really saying where is the slope changing signs? In other words, where is this graph increasing and then decreasing, or decreasing and then increasing? So where do you think?
0, -6.
Yep, so if I'm saying where, I would just say x equals 0. What about x equals 3? Right, x equals 3, increasing, still increasing. What about at x equals 5? Yeah, the rate of change is 0. That doesn't mean we're not changing from positive to negative. Now, if this went back down, then that would be a whole different thing. Okay, where is big F concave down? So what would be my reasoning here? What am I looking for?
F double prime
Which is the same as little f prime is what? Okay, I went ahead and wrote it. That was my fault. But you could say, okay, big F is concave down when the second derivative is negative. You could say something about decreasing, but what you would say is decreasing is just F. Because remember, F is decreasing when F prime is negative. We saw that right up here, okay? A function is decreasing when its derivative is negative, and second derivative being negative means concave down, all right? So where is this function? Either you could say where is the slope negative or where the y values are decreasing. Those mean the same thing. So where would that be?
0.
-3 to 0. Anywhere else? Okay, so those are just, you're not going to be asked every single one of these questions. All right, but these are the different types of questions that can be asked. All right, so now let's look at 2. This is another chart. And the only difference about this is it's the same problem set, but it's saying, okay, we have a different formula. Now we're starting at 2 instead of starting at 0. Is that going to affect the answers? Yeah, it is. All right, so for this one, we're going to start at 2 and go to -3. That's how we're going to do this first one. And so if I go back up to the graph, let me choose a different color. So here I'm starting at 2, and look, if I kind of just color this in, what I'm asking you for is what is this integral? Well, I'm going backwards again. That's a negative. I'm underneath the x-axis, that's another negative, so the result should be positive. All right, so I already know that the left half of this is 9. Like, I already know that that's 9. So I'm just going to find this trapezoid right here and then add them together. So if I think about this, okay, trapezoid, you just take the two parallel sides, 6 and 2, and you average them. So divide by 2. Then you're going to multiply by the distance between the two parallel sides. So what's that result? 8. And it should make sense because if you look at this little piece over here that's missing, that's 1. So it was 9, it's missing a 1, now it's 8. That's another way you could have done it. All right, so 9 and 8, 17. This integral, okay, from -3 to 2 would be -17, but because these numbers are switched, we're going to get positive 17. Okay, what about 0? What's the integral from 2 to 0? Oops.
Negative.
Is it 8 or is it negative 8?
Positive, sorry.
It's below. There's a negative. Where's the other negative coming from?
It's switched.
These two numbers are not in the right order. Your upper and lower bounds are switched, so that's going to be positive 8. Anyone notice a pattern from here to here? Let's try the next one. Yeah, plus 8. So let's try one more to see if plus 8 holds up. What's the integral from 2 to 3? So you're looking at the graph here, and you're saying, oh, okay, 2 to 3, that's in the right order, but still below the x-axis, so negative, how much? -1. So is our whole plus 8 holding up? I don't mean plus 8 from one to the next. What I'm talking about is from my very first table to this table, it looks like I'm adding 8 to these numbers. So it is holding up. So -3 plus 8 would be 5. 15 plus 8 would be 23. So my next question is, why did we add 8? Before we were starting at 0, now we're starting at 2. Do you see why we're adding 8?
Because you lost 8.
Because you basically, yeah, you're kind of making up for that you lost 8 in the first round. If you don't recognize that, no big deal. All you got to do is do the area. Okay, it's not like you couldn't have figured out the answers without knowing this plus 8 thing. All right, and so then we come to this last piece, and it doesn't change the bounds on us, but it does give us this. Does anybody remember what that's called? Something with an I. I-C.
I rock.
Starts with the what?
Initial condition.
Initial condition. And initial condition is what those words sound like. It's basically what you're adding at the very beginning. This is how, like our plus C. All right, now the reason it's big F of 2 is because we're starting at 2. If we were starting at 0, this hopefully would be big F of 0. It's just wherever you start your integral, that's what you're doing. All you got to do is add 5. Okay? So before, when we integrated, we got 17. Add your initial condition, and you would get 22. 17 plus 5 is 22. So just draw what you need to draw here, so that you know. So what would the next one be? 13, 4, 10, 28. Okay, so that was a lot on the same problem set. That was a pretty long problem set. All right, let's go to a released AP test question now. So that if you turn to the next page, all right, and again, I know this packet seems really thick, but you got to think like some of them are these questions. I mean, this takes up half a page in one question. So, all right, so looking at this, this is problem number 1. It kind of starts over. That first page is more like a teach piece. I'm just gonna do these on this page, and then however much time we have left, you can get started on it. So graph of a differentiable function f. Okay, so this is the graph of f. Right? Closed interval. That's always something we're going to see when we think probably we're going to do absolute maxes and mins. All right, and then they give us our equation. So we're going to write that down again. H equals the integral of f. And since I'm integrating what's here, I would write area next to that. H prime would equal just plain f, and that would be the y value. And H double prime would equal f prime, and this would be the slope. I'm highly encouraging you guys to write this every single time you get to one of these problems. Your clue is that they give you an expression and they ask you questions, not about this graph, but about another graph. Okay, this is on the AP test, you are for sure going to see a problem like this. So write this down, and then you don't have to keep it all in your head. Okay, so for A, H of 1, we got to look over here and think, am I doing area, y value, or slope? Which one? Area. So I just use the formula for this. So the formula says we're going to integrate from 1 to whatever this number is, which is also 1. And I can stop right here because if these two numbers are the same, that has to be 0. And what you're doing is saying, what's the area right there underneath that one number, and there's infinite thickness on this, so there's no area. All right, what about h prime of 4? That's going to be the same as f of 4, which is the y value. So I'm going to write that f of 4, which is the y value, which is 2. Very good. Okay, so this is a real AP test. So neither one of these were really that hard to do. Okay, part C says, on what interval or intervals is the graph of H concave up? Justify your answer. So I'm going to leave a little bit of space, and I'm going to write because, and I'm going to go ahead and write my justification to help, and that's going to be good because I need it to get all the points, but also it's going to help me know what to look for. So what would be my justification for H being concave up? So let me say this. We need to use H and we need to use F. You need to use both because one is given and one is given on the graph and one's given on the problem. So we need to say H double prime, which is equal to, and we have it right here, F prime is what? Is positive.
Oh, positive.
If you're going to say increasing, that's not a bad way to do this, but what you need to think for increasing is just F. F is increasing. Okay, so I'm going to put that in parentheses. And if I have all of this, this is like better than good. So F is increasing, or F prime is increasing from here to here, and from here to here. So we're going to write that out as an interval. All right, 1 to 3, make sure you're using x values. The intervals are always going to be x values. And then 6 to 7. Okay, D says find the value of the x at which h has its minimum. So just reading that, does that make you think about relative or absolute? If I said, where is its minimum?
Absolute.
That kind of sounds like definitive, absolute, okay? And so we're going to, like I said, we're going to have a continuing conversation about how to know. But here's another clue. When they really emphasize the whole closed interval, it's leading you into absolute because remember, your absolute min or max can happen at the endpoints. So if they say closed interval, which is basically giving you your endpoints, then probably absolute. All right, so for absolute, we need to determine, kind of running out of, I feel like I'm running out of room here, so I'm going to do the table over here. X and H of X. All right, I need to use both endpoints. I need to figure out what are the Y values. And I also should consider any relative min. So where's the relative min? Okay, the relative min of F is at 6, but I'm saying the relative min of H. This would be where the signs are changing, negative to positive. Okay.
7, but there's.
I will tell you there is none, but let's say you thought it was 5, because 5 is what we would call a critical point. 5 ends up actually being a relative max, but I'll come back to this. Like, in case you thought the answer might be 5, you would figure it out in the very next step, okay? So we'll say there's no relative min of H. All right, so let's do this. I wish I had more room here, but let's go ahead and find H of 1. H of 1 we already found in part A to be 0. Okay, so we'll put that there. What's H of 7? You can't actually find it because these are curves, but you can estimate. All right, so what I'm saying is, what is this area minus that area? First of all, is it positive or negative?
Positive.
Has to be positive. So if I'm looking for an absolute minimum and I'm comparing 0 to a positive number, 0 would have to be the minimum. So I'm going to write like positive number. You could get more specific on this, but the answer here has to be x equals 1. That is the x value that gives you your absolute minimum. All right, so I already said this, but let's say we considered 5, okay, which is actually a max. I'll write it over here, x equals 5. All right, so let's say we did consider 5. We'll look at the area from 1 to 5. H of 5, that's also positive, so it wouldn't have confused you. It wouldn't have been your answer. Does that make sense? Okay, so for relative, you're looking at where the H prime or F prime or whatever you're doing is changing positive to negative, negative to positive. For absolute, you're considering those and the endpoints. Always with absolute, you have to consider these endpoints. Because with absolute, we're just saying what's the highest or lowest point. Okay, let's look at problem 2. It's a multiple choice, obviously. And this says the graph of f is shown. Okay, so this is a graph of f. And then they give us this information. G equals the integral of f. So what would you write? Yeah, some of you picked up on the answer, but I want to make sure we're set on the other ones. Are you falling asleep, Rebecca?
No, that's okay.
Are you making fun of Trey? Now it's on the video. All right, so that's going to be our area. And then G prime, which is equal to F, that would be the Y value. And then G double prime, which is equal to F prime, that would be the slope. Now, you're not going to need this every single time. I'm really just doing this to make a point. If you have all of this down, you can answer anything they give you. Now, they do say, where does G have a maximum? Where do you think the student who doesn't know any calculus, which one is the one they're going to pick?
B.
So that's probably not the answer. Okay? That's an old SAT trick. If it's too good to be true, it's not the answer. All right? So if we want to know where G has the maximum, I want to know where G prime is changing positive to negative, right? Because that's what this would look like. It'd have a positive slope to negative slope. So G prime is the Y values. So where's the Y values changing positive to negative?
C.
C. And then it was like really obvious. Maybe it was obvious to you before I wrote that down. That's great. Feel happy about yourself. All right. But I just want to make sure everybody gets this right. What if they were asking for G of X having a minimum? There is none. Now, did any of you wonder here, like, are they talking about relative or absolute? Were any of you wondering? Okay, it's a good question. So what is maybe, like earlier we said its maximum or minimum, and now you said that kind of sounds more like absolute. This one, what makes you think that it's they're probably meaning relative?
A.
A.
Max.
All right, but let's say you thought they were talking about absolute. You would still get this right because, okay, we know C is a relative minimum. And if you were thinking about it just from an area, right, because that's how you do the absolute, okay, from A to A, because this is where we're starting, that would be 0. From A to C would be positive, all right? And what would happen if you went all the way from A to D? It would still be positive, but less. So C ends up being your absolute and your relative. So they will give you what you need to be able to get the question right. But I'm just trying to help you guys because that's going to make the difference between, you know, a 3 or a 4 or a 4 or 5 for some of you is being able to read those questions. Okay, number 3. Now, if we look at this, it looks like all the other problems. This is the graph of H. This is H right here. So if we were to go ahead and write all this down, this would be great. But it's actually not going to help us with this problem. All right, because the answer choices are graphs themselves. Okay, I'm writing it down just to, you know, you ever wonder why your teachers seem like they just have it all memorized? It's because they write stuff down over and over and over and over. That's how it just gets stuck in their heads. This is how it can help you, all right? So it doesn't help us here because what I could do, I'll just say, you could do this problem by doing all these different areas, creating a table of values, and then seeing which of these graphs that table of values, but that would be so much work. That would be ridiculous. I mean, what they're really asking you is which of these is F, right? And so these are all candidates for F. So F prime should be H. So I'm saying which one of these graphs gives me, if I were to take the derivative, meaning look at the slope of the tangent and all that, which one would give me what I started with? Okay, so let's do this guess and check. Some people are better at this than others. If you think you know, just put a little circle next to whatever you think it is. So if I look at F, what can you tell me about the derivative of this piece of graph? Yeah, the slope of that is positive. So my graph should be above the x-axis, and it is. Okay, what about what's happening at x equals 0? What's the slope right there?
0.
The slope is 0. So if A was the answer, I should be crossing right there, but I'm not. So I already know A's wrong. Here's another way you know A's wrong. What's that called? Cusp. What's the derivative at a cusp? Nothing. Which means you should have some gap in your graph at B, and there's no gap. So I know A's wrong. So I want you to go through, and maybe you've sorted through it in your mind a different way, but I want you to try to find the right answer. That's the closest distractor.
Is it this?
Yes. Wait, no, sorry. That's my fault. It's not that one. Yeah. I'm sorry, Travis.
Dang it. I only got one question right.
That is the distractor. This is right here. This is the one people might pick if they're not careful. It's not because it's so close to the right answer. It's because like, I'll tell you this much. What's like you're going it's the other way around. D is like if you get the two switch, basically.
Oh, and then
I believe.
From positive to negative.
It's like if you take the derivative of this graph, let me make sure I'm doing this right. If you take the derivative of this graph, you do get D. I think so. That's why it's a distractor. What you're thinking, what you got to think is, okay, this is, and that's why I suggest you go ahead and write it on the graph. That's all positive, that's 0, that's negative, and that's 0 again. Well, that matches my graph perfectly. E. If you feel like you just need some more practice on this, I have a really cool website, and if you just email me, I'll email you back the link. And what it does is there's different websites where you go from original to derivative, and from derivative to original, or you match to, or whatever. If you feel like that might help you, and it's online, so you're just clicking. You're not having to it's not multiple choice or anything. Just email me it, and I will. I'll let you know. Okay, here's what I would suggest you get through by Monday. Now, obviously, if you haven't done limits, you should be doing limits this weekend. But just to kind of stay on track and not have a whole lot to do on one night, okay, this is how far you should get done with this packet by Monday. On Monday, we will do a few more on the last part of this packet together, and then you will finish that packet, and then you'll have the extra day to get caught up, and then Wednesday will be the day. So we're kind of overlapping things.